Okay, so on doing problems like this, what we have is sine of u equals 5 over 13, cosine of v equals negative 3 over 5. And we say, OK, well, on the problems on our homework, we could evaluate, right, on the unit circle. Yes? Because we had points that we could use on the unit circle. But when we see something like this where our functions are evaluated, we know these are not points that are on the unit circle, right? So Brittany, I keep on saying over and over that you always have to, when you don't have a point on the unit circle, you always have to create a. Thank you for not letting her think. Give her that time. Just give her that time. You got to have those little synapses and everything in your brain just keeps on getting through, so then the answer comes out. So yeah, you got to go and create a triangle. So now the next thing that most common people do is I say, oh, well, I'll just create a triangle. I mean, who really cares what the triangle looks like? You just got to create a triangle. No, it's not just create any triangle. All right? First of all, this says the triangle has to be in quadrant 2. All right? So that's obviously going to be a big deal. Now, again, if you guys remember, when we were doing coordinate points, there is a very special way that I told you guys to draw your triangle. All right? The first thing that we're talking about when we're drawing our triangle, especially when we have a quadrant restriction, or even not, Josh, is our triangle is going to be perpendicular to our x-axis. That is going to create our 90-degree angle. The next thing that's going to happen about our triangle is that it's going to go to our origin, which is going to create our angle, which is going to be our central angle that we call it. Okay, so now I have created 2 triangles that are in the second quadrant, because that's what it tells me to, right? Then it says this one, the cosine is negative 3 over 5. Remember, cosine for a triangle is adjacent over hypotenuse. So that's negative 3, and that's 5. Sine is opposite over hypotenuse. Now, if you guys remember from your geometry class that you learned Pythagorean triples. So you can use the Pythagorean theorem, but in addition to using the Pythagorean theorem, there's a lot of them that always come up to integers. For instance, that is a Pythagorean triple. 5 squared plus negative 12 squared equals 13 squared. Yep, so that's why I already know that answer. Here, though, I'm going to want to use the Pythagorean theorem. So I'll call that b. So in this case, I'll have b squared plus negative 3 squared equals 5 squared. OK. Oh, OK, yeah. So now in this case, I have b squared equals 9. I'm sorry, b squared plus 9 equals 25. Oh my God, I know what I did. Wow, OK. So I subtract 9, and I have b squared equals 16. Square root, b equals positive 4, right? Because it's up. So you could say, oh, Mr. McLogan, that's another Pythagorean triple, right? But if you guys didn't notice the Pythagorean triples, the 3, 4, 5, you can always use Pythagorean theorem as a default. All right? So now, what they're asking us to do, though, in this case, I'm sorry, I didn't even write down the problem. They're asking us to do is the cosine of u minus v. So to do the cosine of u minus v, what we need to do is obviously apply the formula. Well, for cosine, it's cosine of u times cosine of v plus the sine of u times the sine of v. So now we just plug in what we have here. Cosine of u. Here's my angle u, right? Adjacent over hypotenuse. Cosine of v, negative 3 over 5. Plus sine of u, 5 over 13. Sine of v, 4 over 5. Does everybody see how I got those points and where I came up with all those values? Is everybody cool with that? Cool? All right. So now I just multiply across. Negative 12 times 3 is going to be 24, 40, 36. 13 times 5 is going to be 15, so that'd be 65. 5 times 4 is 20. And then you add them up. 56 over 65. And then we always want to see, is there any other numbers that are going to add into there or divide into both of those? No. Okay, so that's it. Got your simplified answer. Cool.